Welcome to the Organic Chemistry. Today, we will understand valency, the bonding power of an atom. Valency means the combining capacity of an atom. It tells us how many electrons an atom can lose, gain, or share to become stable. Let us look at some common elements and their valencies. Hydrogen has valency 1. Oxygen has valency 2. Nitrogen has valency 3. Carbon has valency 4. Sulfur can show 2, 4, or 6 valency, and chlorine usually has valency 1. Now let us see valency in action with examples. Water whose hydrogen has valency 1 and oxygen has valency 2, so oxygen forms 2 bonds with hydrogen. Ammonia, a nitrogen, has valency 3, so it bonds with 3 hydrogen atoms. Methane, carbon, has valency 4 and forms 4 bonds with hydrogen. Hydrogen sulfide is sulfur with valency 2, forms 2 bonds with hydrogen. Carbon dioxide, carbon, forms double bonds with oxygen because carbon has valency 4 and oxygen has valency 2. Sulfur dioxide, so sulfur forms double bonds with oxygen based on its valency. Easy way to remember: hydrogen 1, oxygen 2, nitrogen 3, carbon 4, sulfur 2, 4, 6, and chlorine 1. Understanding valency helps us learn chemical bonding and molecule formation easily. Carbon is represented by the symbol C and has atomic number 6. What does atomic number 6 mean? It means carbon contains 6 protons in its nucleus and 6 electrons in a neutral atom. Now let us understand the electronic state or electronic configuration of carbon. Carbon has a total of 6 electrons. These electrons are arranged in shells. The K shell contains 2 electrons, and the L shell contains 4 electrons, so the shell distribution is 2, 4. The electronic configuration of carbon is 1s2s2. Now let us understand the ground state. Ground state means the electrons are in their lowest energy level. In carbonous ground state, the configuration remains 1s2s2. Here, carbon has 2 unpaired electrons, so its apparent valency is 2, but carbon usually shows valency 4. How does this happen? For that, we need to understand the excited state. In the excited state, 1 electron from the 2's orbital gains energy and moves to the 2p orbital. Now the configuration becomes 1s2s2. This creates 4 unpaired electrons. Because of these 4 unpaired electrons, carbon can form 4 covalent bonds. That is why carbon shows valency 4 and forms millions of organic compounds. So remember this key point. Ground state, 1s2s2, valency 2, excited state, 1s2s2, valency 4. This excited state is the reason carbon becomes the backbone of organic chemistry. How to find sigma and pi bonds in molecules with simple rules and examples. First, let us understand what sigma bond or bond means. A sigma bond is formed by head-on overlap of atomic orbitals. It is the strongest type of covalent bond and is present in every single, double, and triple bond. Remember this simple rule. Every single bond contains 1 sigma bond. Now let us understand pi bond or bond. A pi bond is formed by sideways overlap of p orbitals. Pi bonds are found only in double and triple bonds. Easy rule to remember: single bond 1 bond, double bond 1 plus 1 bond, triple bond 1 plus 2 bonds. Now let us learn how to find sigma and pi bonds step by step. Step 1. Draw the correct Lewis structure of the molecule. Step 2. Identify whether the bonds are single, double, or triple. Step 3. Count sigma bonds. Every bond contributes 1 sigma bond. Step 4. Count pi bonds. Double bond has 1 pi, and triple bond has 2 pi bonds. Step 5. Add them to get total sigma and pi bonds. Now let us see 5 examples. Example 1. Hydrogen. Each hydrogen has 1 single bond, so sigma 1 and pi 0. Example 2 oxygen. Our oxygen has a double bond. A double bond means 1 sigma and 1 pi bond. Example 3 nitrogen. And nitrogen has a triple bond. Triple bond means 1 sigma and 2 pi bonds. Example 4 ethene. Ethene contains 1 carbon-carbon double bond and 4 carbon-hydrogen single bonds. Total is 5 sigma bonds and 1 pi bond. Example 5 ethine. Ethine contains 8 carbon-carbon triple bond and 2 carbon-hydrogen single bonds. Total becomes 3 sigma bonds and 2 pi bonds. So remember this shortcut. Count all bonds for sigma. Count extra bonds in double and triple bonds for pi. Sigma bonds give strength, while pi bonds provide extra bonding and stability. Keep learning chemistry and keep growing.